All right, what I want to do now is talk about forward rates and the relationship between forward rates to spot rates. So the idea of a forward rate is very simple. It is simply the one period, generally speaking, 1 year period, equivalent interest rate corresponding to the term structure of interest rates. And so we're going to use this notation for this 1 year interest rate from a time period t minus 1 to t. The zero here, as usual, um, denotes the fact that we're investing money now. So we have a term structure of interest rate, corresponding to investing money now. Okay. So there's not standard notation. This is from Broverman's book. Some people use the F notation. They have an F, something here and something here. You could have a forward rate for more than 1 year, but I don't think Exam FM uses forward rates for more than 1 year. Okay. So the idea is as follows. Let's say we have a 3-year spot rate corresponding to investing money right now. Let's say I invest $10 right now. Okay. So by definition, that sits an account for 3 years, earning R3 interest per year. Then we compound that for 3 years. It's $10 becomes 10 times 1 plus R3 cubed. It's just 3 years of growth at interest rate R3 per year. We can instead specify this growth by a yearly interest rate from 0 to 1, from 1 to 2, and 2 to 3. Okay. Or let's, instead of actually doing that, let's do something instead. Let's say we let this $10 sit in this account for 2 years. And if we do that, we're going to use a 2-year spot rate. Okay. So that means 10 years grows to 10 times 1 plus R2 squared. Now, let's say we want the exact same growth as if we are using the 3-year spot rate, and hence we're letting money sit in this account for 3 years, but we want to figure out what the equivalent interest rate from t equals 2 to t equals 3 in this 1 year 1 year interval. We want to figure out what that interest rate is from year 2 to 3 that corresponds to the same growth as given a 3-year spot rate. Okay. So in other words, if we have this interest rate from year 2 to year 3, then 10 times 1 plus R2 squared becomes, well, 10 times 1 plus R2 squared times 1 plus this interest rate here. And this I023 is exactly what the interest rate from year 2 to 3 is going to be denoted by. Okay. Well, so this is how $10 grows in 3 years. But again, by definition of the 3-year spot rate, $10 grows to 1 plus R3 cubed. So the conclusion is 10 times 1 plus R3 cubed is 10 times 1 plus R2 squared times 1 plus I023. That's basically the idea of the spot rate here. It's a 1-year interest rate from year 2 to year 3 that corresponds to the time structure of interest rates. Okay. Now, what we could do is instead we can think of this as I kind of was starting. We can think of growth in terms of just simply 0 to 1, 1 to 2, and 2 to 3. Okay. So $10 becomes 10 times 1 plus I0, 0 to 1. Let's say I0, 0 to 1 is this interest rate from 0 to 1. Okay. Let's say I0, 1, 2 is the interest rate from 1 to 2. So this amount grows to this here, multiply $10 by these two corresponding growth factors, and multiply this here by 1 plus I0 2 to 3. I0 2 to 3 is the corresponding interest rate for this 1-year period 2 to 3. Again, and sorry, I forgot a 10 here. There should be a 10 here. It's 10 times this whole thing here. It just couldn't fit, but there should be a 10 right here. Okay. But again, by definition, R3, 1 plus R3 cubed is the corresponding growth for 3 years. So we conclude that this also equals 1 plus I0, 0 to 1, times 10 times I1 plus I0, 0 to 1, times 1 plus I0, 1 to 2, times 1 plus I0, 2 to 3. Okay. So, if you're being astute, you should think and understand and recognize that, well, really the 1 year spot rate is exactly I0, 0 to 1. The 1 year spot rate is the interest rate you get if money sits in this account for 1 year if you invest it now. Well, the 1 year interest rate that money gets if you invest now and it sits for 1 year. Well, that's exactly what I0, 0 to 1 is. It's the interest rate if you invest now from 0 to 1. Okay. All right. So if you understood this, and again, there should be a 10 here. If this makes sense, then these basic formulas should make sense after, I'll still derive them, but it's very easy to derive them with the logic used here. So we have the basic formula I0 t minus 1t is 1 plus RT to the t over 1 plus RT minus 1 to the t minus 1 minus 1. Now, it's a mouthful, but let me show you where that comes from. And the idea is a very, the idea is a very simple one. Okay, the idea is as follows. I got to go to the whiteboard. Okay, so we have we're going to do t years of growth in 2 different ways. Okay, so instead of 10, let's just do $1. So let's say $1 grows to well, if $1 sits in the account for t minus 1 years, just 1 times 1 plus r t minus 1 to the power t minus 1. Okay. And if we have a spot rate of I0 t minus 1 t for this year here, t minus 1 to t, so we have a 1 year interest rate from t minus 1 to t, then this amount here grows to, see if I can fit it, 1 plus RT minus 1 to t minus 1. Well, it's just this amount grows corresponding to this 1 year interest rate, so it's 1 plus this interest rate. 1 plus I0 t minus 1 t. Okay. Well, by definition, $1 after t years just simply grows to, well, you should know it grows to, using the t year spot rate, 1 plus RT to the t. Right, so in other words, what I have here, oops, didn't want to do that. These two are equal. Okay. So we have that 1 plus RT to the t is going to be equal to 1 plus RT minus 1 t minus 1 1 plus I0 t minus 1 t. So just solve for this forward rate right here. Solve for this. divide by 1 plus RT minus 1 and the T minus 1, subtract 1, we get our formula. So, right. Yeah, so that, right. So solve for I0 T minus 1T, we get this formula. Okay. Okay, so a very plug and chug example here. Let's just do this real quickly. So I won't use the calculator per se, but I'll just pop it up here. I trust you can plop the formulas into the calculator. But anyway, all right, so given this term structure of interest rates, find the 1-year forward rate for years 1, 2, and 3. Okay. Right. So to be clear, so actually, let's see. So actually, let's do this for years 2, 3, and 4. So let me do that for years 2, 3, and 4. So here, year 2 is year 2 is 1 to 2. Year 1 is 0 to 1. I don't really want I01. That's just the 1-year spot rate. So let's do years 2, 3, and 4. Again, year 2 being 1 to 2, year 3 being 2 to 3, year 4 being 3 to 4. Okay. All right, so right, so I want I0 of 2 to 3 and just throw it into the formula. It's 1 plus R sorry, I want for year 2, I want 1 to 2. So it's 1 plus R2 squared over 1 plus R1, well, to the 1 power minus 1. And if you go back to the table, this is 1.029 squared over 1.027 minus 1. And you get about 0.3, 3.1%, 0.031. So let's go back real quick and take a look at this. Right, this is the 2-year spot rate, and this is the 1-year spot rate. Okay. Next, we're going to use the 3-year spot rate, and then the 2-year spot rate, and then we're going to use the 4-year spot rate, and then the 3-year spot rate. So I'll just quickly do these other problems and get to more interesting examples. So taking a look at the sample exam FM problems, these spot rate problems are surprisingly simple. I think I said in a prior video that they're going to give you really tough problems. I haven't really seen anything too hard, but maybe I can say that because I've taught this 5 or 6 times. But anyway, whatever. All right, so it's 1 plus R3 cubed over 1 plus R2 squared minus 1. 1.034 cubed over 1.029 squared minus 1.04407. Last but not least, let's get the 4-year spot rate. Again, year 4 is 3 to 4. Well, 1 plus R4 to the 4th over 1 plus R3 cubed minus 1. 1.038 fourth. over 1.034 cubed minus 1 is about 0.05. Okay, so yeah, another basic formula is the following. To get the spot rate from the forward rates, you just multiply raised to the 1 over t minus 1. Okay? So you multiply the first t forward rates, right? Corresponding to year 1, year 2, all the way to year t. Okay. And this just file, I'm not going to go through it, but this is just the same logic as this here. You know, just 3 years of growth is the same thing as compounding each yearly growth. So just divide by 10 in this example. Raise this 1 plus r3 cubed to the 1/3. That's going to equal 1 plus the 1 year spot rate times 1 plus the 2 year spot rate plus 1 plus the 3 year spot rate to the 1/3, subtract 1, and we get R3. So yeah, this just same logic for t years as I'm doing here. Just simply solving for R3, you would get exactly this when t equals 3. Okay. All right, so let's do something. Let's check our prior answers using this formula to compute R3 and R4. Okay. All right, so right, so I have the first. Yeah, so I have I have I0, 1, 0. The first forward rate is just the same thing as the first spot rate. So that's 2.7. So let me just go to the calculator here. Actually, yeah, so I'll go to the calculator just yet. Let me go to the whiteboard real quick. So I'll just go up here. I0, 0, 1 was what was it? R1 2.7%, so 0.027. All right, so I'm going to use these rates here. So maybe write it down because I can't have the whiteboard and the calculator up. It's very annoying, but that's the way Zoom is. All right, so let me go back. So yeah, write these down if you want. 1 second. All right, so 1.027. Let's get R3 first, times 1.031. 3.1% is the year 2 forward rate, times 1.04407. That's the 0.04407 is the year 3 forward rate. Raise that to the 1/3. Minus 1 and convert it to a fraction. We get 3.4% for the 3-year spot rate R3. That's exactly what I have here, rounding, just doing some rounding, 3.4%. Okay. Now let's get R4, then we'll finish off with to not too hard but annoying exam FM problems from the SOA exam FM sample problem website. All right, so R4, same thing. Except we multiply everything by 1.05 and then raise it to the 1/4. So it's 1.027 times 1.031 times 1.04407, just multiplying the year 1, 2, and year 3 spot rates. Now finally times 1 plus these spot rates. Now finally multiply this by 1 plus the year 4 spot rate times 1.05. Whoops, didn't want to do that. Raise this to the 1/4 minus 1, convert it to a decimal, and we get the 4-year spot rate is 3.8%. Exactly what I have here, just rounding. Okay. Okay. So yeah, a little easy example. Basically the same thing as we did before. So here is the prices of zero coupon bonds. And here, I don't know why or how they're assuming you can figure out that implicitly the redemption value is $1. I mean, it's reasonable, but yeah, it doesn't make any sense to me. So this is the price for a redemption $1 zero coupon bond. Calculate the 1-year forward rate, deferred 2 years. So what this means is we're finding the 2-year forward rate. So this might be a little confusing. Actually, this is going to be so deferred 2 years means we're starting at t equals 2. So it's 2 to 3. Deferred 1 year would be 1 to 2. Not deferred would be 0 to 1. So I guess in that regard, it makes sense. Deferred 2 years, 2 to 3. So we're finding I0, 2 to 3. Okay. Okay, so yeah, maybe write these down if these prices. So we actually just need these two prices, the 3-year and 2-year zero coupon bond prices. All right, so I'll remind you of how a zero coupon bond works. It's extremely simple. So the idea is that very simply, I get $1 back after let's do 3 years. I pay P and I get $1 back. So so yeah, actually this price here we're given, if you go back, I just want to double check this real quick. Yeah, we're given the prices about 86 cents. So it's not really P. This is 0.85892. All right, so let's say we have a 3-year spot rate. So what this means is we're basically taking the present value of $1. So maybe it's a little clearer going the other way. I mean, same thing, but so we're taking the present value of $1 corresponding to this 3-year spot rate. You can plop this into a calculator and solve for R3 is 0.052. want to check it myself real quick. 0.0592. Sorry, bear with me for a second. Yeah, there's literally 1, 2, 3, 4 zeros after the 2 here. So all right, and the same idea for the 2-year 0 coupon bond. So the price here is roughly 91 cents. It's 0.90703. That's what the table gives me. So the 0 coupon bond gives me a $1 redemption. So the price is just present value. And we take that present value, discount 2 years with respect to 2-year spot rate. Take present value with respect to this 2-year spot rate. 0.90703, and let me just get this real quick. And it's 0.05 rounding. Sorry, R2. And the whole point is we need R2 and R3 to get I023 via our formula. So this is 0.05. All right, so finally, plop into our formula. I023 is 1.052 cubed. It's 1 plus R3 to the 3. So this is, I'll just write it like that. Move this over a bit. I have plenty of room. One plus R3 cubed over 1 plus R2 squared. 1.052 cubed over 1.05 squared minus 1. 1 point, R3 is 0.052. So. And this is going to be 0.056, so 5.6% about. Let me just double check that. I know it's probably annoying because you can't see the calculator, but anyway, yeah, it's 5.6%. Okay, and let's just check that because we have multiple choice, at least answers here. So this was problem 67. Uh, 67. And lo and behold, 0.056 is here. 0.056 is right here. So it's E. All right. All right, now on to this last problem. This is an absolute just a sea of words, just verbiage, vomit. I don't know how else to put it. Just a lot of words. But it's actually a very simple problem if we just think about this logically. So Joe must pay liabilities of 1,000 due 1 year from now, and another 2,000 due 3 years from now. There are 2 available investments. We have 2 bonds. One is a 1 year 0 coupon bond that matures for 1,000. The yield rate is 6%. a 2-year zero coupon bond with face amount of 1,000, the yield is 7%. So what's interesting of this problem is, as I'll explain in a minute, the face values and the maturity is absolutely irrelevant. But anyway, at the present time, the 1-year forward rate for investment made 2 years from now. So this is again I0 to 3 is 6.5%. Joe plans to buy amounts of each bond. Right? So it's irrelevant what the face value. I mean, it doesn't really have much meaning anyway, because you just you purchase it, and the redemption you get is given by the yield rates. Okay, you purchase X of bond. Well, I'll go through it and I'll explain why this is irrelevant, and maybe it's just made to confuse you, to state it to confuse you rather. Okay, so he plans to reinvest the proceeds from bond 2 in a 1-year zero coupon bond. Assuming the reinvestment earns the forward rate, calculate the total purchase price of bond A and bond 2, where the amounts are selected to exactly match the liabilities. Okay, so right, the idea is you have bond 1, the 1-year zero coupon bond. You need to use that to pay off the 1,000 because bond 2 is reinvested, and then that reinvestment is going to be used to pay off the 2,000. Okay, so we're going to use bond 1 to pay off the 1,000, and bond 2 to pay off the 2,000. Just add up the 2. All right, so yeah, and yeah, if you're watching this, you could go to the website. This is 53. Sure. Yeah, so you could go to right here and just keep this open. So you watch this. If you're watching this and you're in my class, this is right here. I should say there's actually a YouTube channel of every single one of these problems solved, which is a hell of a lot of problems. It's 100, I think over almost 200 problems. So 200 videos here of solved exam FM problems. To tell you, a lot of people probably appreciative of this woman who did these videos. I know I am, because I absolutely check my answers with her. Though if I dare say my way of doing things, I think is a little simpler than hers, but anyway. All right, so let's get this done because it's late here and I want to go to sleep soon. About 10:30. Okay. So yeah, like I said, this is actually surprisingly straightforward. So let's say X is the 1-year bond price, and this is a zero coupon bond, so very straightforward. Okay. So the 1-year yield rate for bond 1, or the per year bond rate, is 6%. So the way this works is 2 ways you can, well, the way I think the easiest way to think of this is you purchase this for X. That X in 1 year grows to 1.06X. Remember, zero coupon bonds just behave like normal one-time investments under a certain interest rate. That interest rate is 6%. So it's 1 year of 6% growth. And this is used to pay $1,000. So 1,000 equals 1.06x, and just solve for x, you get 9.43 and roughly 40 cents. And it's 1,000 because you need 1,000 take care of that first liability. You have $1,000 liability due now. So X is, yeah, like I said, 943, about 943.40. I'm just going to add this to the price of bond Y. So I don't really need to round too much more. Okay, so let's say Y is price of bond 2. Okay. All right, so I just want to go back real quickly to this here. All right, so you purchase this bond 7% per year, the 2-year bond, and then after 2 years you invest you invest the proceeds of bond 2, the total accumulated value from bond 2, into an account earning a 2 to 3 forward, I0 to 3, that interest rate of 6.5%, that forward rate. The forward rate, the 1-year forward rate 2 years from now. So now 1 year now would be 0.1. 1 year from now is 1 to 2. 2 years from now, 2 to 3. The forward rate kind of now would be 1 to 2. The 1-year forward rate. Sorry. The 1-year forward rate now would be 0 to 1. 1-year forward rate 1 year from now is 1 to 2. 1-year forward rate 2 years from now is 2 to 3. Probably not very complicated, so I probably did not need to say that. All right, so let's put that all to good use. Okay. Yeah, kind of, again, surprised that this is that's on here, because it is a very straightforward problem. Okay, so we have Y here. Okay. So we have a per year yield rate of 7%. So this Y here grows 7% per year. Okay. And we have from year 2 to 3 a 1-year spot rate of 6.5%. So we take this amount and dump it into some account, earning a 1-year spot rate of 1.065. So this is going to be equal to, we're going to use this to pay off the $2,000 liability at the end of 3 years. So let me just check this. 1.07 squared times 1.065, 1 over that times sorry, screwed that up. Bear with me. So we get Y is $1,640.26. So just divide by 1.07 squared times 1.065. You get Y is 2,000 over 1.07 squared times 1.065. And so yeah, the problem is asking for this Y plus this X. So you add these two up. 943 40 plus 16 40 26 25 2583.66. Let's hope that's somewhere in this sorry, having some trouble here with the stupid digital pen. Yeah, let's go back and check that this is somewhere here. It's here when you oops, sorry. It's here when you round up 2584. So this is going to be A. 2583.66 rounds up to 2584. Okay. So yeah, and there's not too many problems with forward rates. There's one 119. I was thinking of doing it, but it's really just plug and chug. It's very easy. Try that yourself. But yeah, that's it. So next up is duration, and you might want to review differentiation. Because duration is literally a measure of the rate of change of the relative rate of change of price with respect to yield rates, interest rates, same thing. You'll see people, I've seen multiple finance websites try to explain it without using calculus, and it just doesn't make any intuitive sense to me. It's a rate of change. Calculus is how you do rate of changes. It's a relative rate of change. You need calculus to make sense out of relative rate of changes. It's really that simple. So review your Calc 1. And yeah, hopefully this was useful. So long, take care. And the end is near. We're almost done. And I really, really, really hope to get through everything that's on Exam FM. So yeah, so long, take care. Bye-bye.